My name is Dmitry Jemerov, and I work for JetBrains, and one of the projects that I'm involved in is Kotlin. So before I'm going to start talking about Kotlin itself, I'd like to say a couple of words about JetBrains. You may actually be already familiar with the company because its headquarters is right here in Prague. We also have offices in St. Petersburg and in Munich. And we are in the business of building developer tools. So our flagship products are IntelliJ IDEA, a Java IDE, and ReSharper, a plugin for Visual Studio, also providing productivity features. We also have a bunch of smaller IDEs, such as for Ruby, Python, PHP, JavaScript, Objective-C. And we have some team-oriented development tools. So TeamCity is a continuous integration server, and UTrack is an issue tracker. And one of our newest products is Kotlin. So what is Kotlin? Kotlin is a statically typed, JVM-targeted, open source, general purpose programming language developed by JetBrains with help from the community, and available right now. So it's not yet released, it's still in development, but we just released the M2 build this week, and you are welcome to give it a try. So why did we start working on Kotlin? So why do we need another JVM language? So the work on Kotlin started about 2 years ago, and by that time we had the code base of IntelliJ IDEA. Our flagship product was already very large. It was more than 50,000 classes, and it contained support for a lot of nice languages for JRuby, Python, Scala, Groovy, and so on. And yet, despite this, the IntelliJ IDEA itself was still written almost exclusively in Java. And so we were actually unable to use all of the features of those nice languages. So what do we need from a language to be able to use it for our own products and for people to be able to use them in similar products elsewhere in the industry? So first of all, we need to have full Java interoperability. So unlike Phantom, we treat Java as something like foreign, so it has a foreign function interface for calling Java code. For Kotlin, Java is the first-class citizen. So all of the features of the language, primitive types, generics, arrays, all of it is fully supported in Kotlin. Second, we need to have a language that compiles and runs as fast as Java. So we spent long enough time waiting for our code base to compile as it is now, and we would simply be unable to use a language that takes twice as longer to compile. We need to have a language more concise, less verbose than Java. We want to have a language that is safer than Java, that prevents more kinds of errors, for example, null pointer exceptions. We want a language that is simple enough to learn, that does not require a PhD in order to fully understand. And actually, some pieces of Java itself are very tricky and very complicated, like generics, and few people understand them completely. And we want to avoid having these kind of words in our own language. And obviously, since we are a tooling company, we need a language to have efficient tooling right from the very beginning. And of course, many of the features in this list are available in some of the languages. For example, I don't know, Scala is very concise. It's very good at preventing errors, but on the other hand, it's very complicated, and it takes a long time to compile. And for the combination of features, at that time, no language existed that provided this kind of combination. So before I go into the details, I'd like to focus on a couple more points. So first of all, performance. So the bytecode that Kotlin generates, since it's a statically typed language, the bytecode is very similar to Java bytecode. It's very straightforward, so it's very easy for Hotspot to optimize for the Java virtual machine bytecode compiler. It does not have any constant runtime overhead. It does not use boxing for primitive types, so you can have a collection, an array of integers that's actually an array of integers at JVM level. There is no performance cost to using Kotlin. And the second point is about the easy-to-learn part. So when many people hear presentations of Kotlin, their reaction afterwards is, well, there's not too many exciting new features. But that by itself is a feature of Kotlin. We are not in the business of developing new, innovative, groundbreaking features. We are not going to publish any research papers on Kotlin, or probably not going to. And instead of that, we are building on the experience that has already been accumulated by other languages, and letting people reuse their skills, reuse what they already know from working with other languages. So I've listed some of the languages that have been our inspiration. Some people actually, for some reason, think that Kotlin is a clone of Phantom. And I would be very interested to discuss why do they think so, because Phantom was not even a major inspiration for us. So it's superficially similar in some places, and like features like nullability is handled in a similar way in Kotlin, but still there is still a lot of differences in the approach. So, tada, the big reveal, the hello world. So I'm going to show a series of code samples right now. If there is something that you do not understand, that is not fully clear from my explanation, feel free to interrupt and ask me the question right away. So and I will explain everything to you as I go. So the features that you see here are fairly obvious. So you don't have to put semicolons after all of the statements. You don't have to put all of your static methods in classes like in Java, so you can just put them. So you can have top-level functions just like in C and in many other languages. You have types on the right. We don't have any special syntax for arrays, so it's just a library type. So this actually maps to the real Java array type, but in Kotlin there is no special syntax for that. Yeah, and println is a library function for printing stuff. Very easy. The next example is a bit more interesting. It's how we define a class in Kotlin. And the first thing that springs to the attention here is this thing in parentheses here, and this is called the primary constructor. And the primary constructor does two things at once. So first of all, it declares the parameters that you need to pass in when constructing the class, and second, it exposes those parameters as properties. So in this case, I have put a val in here, and this val means that the user class will have a read-only property called name. And in Kotlin, we distinguish between val and var, and var is something that can be changed, and val is something that cannot be changed. That's like constant phantom, or almost like constant phantom. The next thing that we see here is that if we have a function with the body consisting of a single expression, you don't have to put in the block, so curly braces, and you do not need to specify the return type. You just put an equal sign and the body of the function. And just like in many other languages, like Groovy or like Phantom, you can put dollar expressions inside a string, and these are references to the variables in the surrounding scope. And unlike some other languages, Kotlin statically type checks this. So you can write here $name because there's a name variable here, but you cannot write, I don't know, $last name here because there is no such variable. So it's guaranteed that all of these variables actually exist. And finally, one last point, that you don't need to put new in constructor calls. You just put in the class name and then the parentheses, and this creates an instance of the class. So all right, everything's clear? Okay, moving on. The next feature is called traits. It's actually very, very, very similar to Phantom's mix-ins. So we are using a different name, but the essence is the same. So there is a function, there is an abstract function isEmpty, which needs to be defined by the class into which inherits from the trait. And there is a function, there is a concrete function contained stuff that uses the isEmpty function in its implementation. And now we have a myList class that inherits from ArrayList and also adds the stuff container trait. And now that we have defined this class, we can use the containStuff method just simply by calling it. And I have to note that traits are not a full implementation of multiple inheritance, so they are actually even more restricted than scarlet traits, if you're familiar with those. So in Kotlin, traits may not have any state. So you cannot have any fields or any properties with backing fields, as we call them in Kotlin, inside traits. So you can have method declarations, and you can have method bodies, but no state. And this lets us avoid like the problem of inheriting the same class through multiple chains, so the diamond inheritance problem. And we avoid this kind of issues. All right, moving on. So the next feature is extension functions. This one is probably familiar to you if you have programmed C#, but in Kotlin we are running even further, and actually extension functions is the feature that gives Kotlin much of its distinguishing flavor. So let me explain what's going on here. So first of all, we are defining the iterator function on string. And inside the body of the function, we can reference to this, this. And this means the instance on which we have called the iterator function. This is just a class that implements the iterator that goes over the characters of a string. And it should be fairly clear by now what's going on here. The only new thing here is the syntax for properties. So obviously Kotlin has first-class properties, and you can define getters and setters for the property, and this is the syntax that you use for this. So get, and you can also have a setter which is also defined in a similar way. And finally, this for loop, just like in Java, it's actually for each loop, it's actually expanded to calling the iterator method, and then calling has next on the iterator until it stops, until has next return false. And since we have defined the iterator method on a string, we can use string in this context, which we cannot actually do in Java. And the implementation goes through all of this code that is here above. And speaking of extension functions, it's a good time to note that in Kotlin we want to avoid developing our own libraries as much as possible. So for example, Phantom has an extensive runtime library. Scala has its own collections library, which is very full-featured and rather hard to understand, I would say. In Kotlin, we are going to reuse the Java libraries as much as possible. But on the other hand, the extension functions allow us to define, to extend the Java libraries in order to make full use of features like closures and other stuff, and other nice stuff that we have in Kotlin. And at the same time, we avoid, for example, the need to copy data from one kind of collection into another when you interoperate between Kotlin and Scala code, Kotlin and Java code, sorry. So extension functions allow us to put a very nice face around the existing Java APIs. But, yep.
What's the namespace of the extension function?
The extension function is, so when you import a package, the extension functions defined in this package, they become available in the scope.
And what happens when you have a library with extension function for the same object?
I think it's a compiler errors. So you cannot import two different libraries that define the same extension function. So moving on, functional literals, or in other words, closures. So we start with defining a list of users. So so you will probably note that unlike Phantom or unlike some other language, we don't have any syntax for collection literals. So because Java has many different types of collections, and in some cases you want to create each of them, and because of that we don't put any like square brackets or something like that syntax in the language. Instead of this, we use those helper functions that make it very easy to define the specific kind of collection that you need. And the next thing that we do, what's going on here? Okay, so it's not escaping anymore, that's good. So the next thing that we do is called the map method. And the map method essentially takes every element of the array and applies a function to it and returns the result of it is collected in another array. So Phantom has something like this as well. You have seen it already in the previous presentation. And this thing here is like the longhand syntax for declaring a functional literal. So a functional literal has a number of arguments. We can define types for them. And the body of the function is to the right-hand side of the arrow. But in this particular context, you notice that we are using a shorter syntax. And we are using actually a number of syntax shortcuts that Kotlin gives us. So first of all, we have this it variable. It's just in the same way as in Groovy or in Kotlin, in Groovy or in Phantom. It is simply the first the only parameter of a function literal. So if you have a function that takes one parameter, you can just name it it and let the type be inferred. And it's just a shorter syntax for expressing them. And second, if you have a function that accepts a single function literal argument, then you can omit the parentheses inside around the call, and you can also, or if you have some, you can put the function literal outside of the parentheses. So it's very nice DSL-like syntax. And the final thing that we see here is the way to embed an expression inside the string, just nothing fancy, just like in Phantom or just like in Groovy. Just call it, just it's called when the function is evaluated. Everything's clear? Yeah, obviously function literals also can work as closures. So inside of the body of the function literal, you can access variables from the surrounding scope. So we don't do this in this example, but if you need this, it's certainly available. The next example shows how you can overload operators in Kotlin. So unlike some other languages, we do not support the ability of defining your own operators. So you can only redefine the operators that already exist in the language, like addition, division, multiplication, and so on. And to each of those operators corresponds a name of a function. So for example, the minus function corresponds to the minus operator. And in order to overload the operator, you simply define the function with the corresponding name on your class. And once you do that, you can simply use this operator, and this translates to the call of the function. So this minus actually means calling this function. And the second interesting thing that we are using here is extension properties. So we are not simply defining extension function on class string, we are defining extension property. And essentially, it's simply a shorter syntax for doing the same thing. So extension properties cannot have any state, so you cannot associate a state with an additional state with an arbitrary instance of a Java object. This does not happen in Kotlin. But you can define an extension property that has a getter, and this syntax will lead to a call of the getter. Yeah, and the priorities of the operators are also fixed by the syntax of the language. Everything clear? Yeah.
What's the scope of the extension properties?
The same as extension functions. So if you import the names package which defines the extension functions, then you can use the extension properties, then you can use them. So the next feature is nullability. So thankfully, I do not have to explain this probably in much detail as I would, because it's quite similar to what Phantom does. The big difference is in Kotlin, unlike Phantom, all of the nullability is checked at compile time. So all of these errors are not runtime. These are all validated by the compiler, and you will not have a runtime error if you mess up with your nullability. Other than that, it's all fairly similar. So for every reference type, you have to declare whether it can contain nulls or not. And this also applies to method return values. For example, in this case, we see the list files method on the java.io.file. And this files method returns an error reports an error by returning null. So if we simply wrote this similar code in Java, then it will throw a null pointer exception, because the list files method on a file which is not a directory will simply return null because Java is unable to get the list of files. And Kotlin does not allow you to write code like this, so this will simply not compile. You will get this error at compile time. So how do you avoid this kind of errors? So there are multiple solutions. So first of all, you can use the save call syntax. This is just like in Phantom. So this is a save call operator, which means call the method or return or take null if the receiver is null. And this is the ls operator, which means that if this is null, take the right-hand side, this. And if this is not null, then simply take the left-hand side. So this means that if we are able to get the list of children, then we return the size of the count of children. And if we are not able to get the list of children, then we return 0. And in some cases, this is the right approach. And in other cases, there is a different approach that you can use. In Java, obviously, to avoid null pointer exceptions, you write null, you check for null. So if something is not null, then we proceed and move on. And in Kotlin, you can also do the same thing. So you can store the list of files in a variable and check it for null. But the Kotlin compiler actually understands the semantics of the check. And it understands that once you have checked the value for null, you can access this freely without any additional checks and without any compile time errors. So if you know that you actually have a list of files, you can simply get their size, and this will compile. And by the way, this green highlighting is actually provided by the IDE plugin, by the IntelliJ IDEA plugin, and it shows that this variable has automatically been typecasted because of the checks that you have made around the code. And obviously, this kind of checks only works for vals. So if you have a mutable field or a mutable variable, then you cannot use this kind of data flow analysis, because the variable can be changed elsewhere, and so the compiler does not allow you to do this thing. All right? The next feature that I'm going to talk about is in some ways an extension of the previous one, namely in the smart cast part, and the second part is pattern matching. So pattern matching is essentially Kotlin's answer to the Java switch statement. So we don't have any switch statement in Kotlin. Instead, we have the when expression. And when expression has two major differences. First of all, as you can see here, it can return a value. So this whole thing is not a statement, it's an expression. And it returns different things depending on what you pass in as a parameter. The second big difference is you are not restricted to comparing the value with a number of constants, just like in Java switch. So you can do that if you want. But if you want something more, you can do more extended, you can do also other kinds of checks. So for example, in this case, we are checking the type of the value. So if it is number, get its value. If it is a sum, then take the left part of the sum and the right part of the sum and add them together. If it's a multiplication, do the multiplication. And if it's something else, then obviously we need to do something, we need to return something, and because we cannot return anything meaningful, we throw an exception. And you will also notice this green highlighting here. So again, we are doing something fancy based on the static checks. And what we are doing here is we are letting you access the properties of the class without requiring you to write an explicit typecast as if you would need, you would need in Java. So once you know that E is actually a number, then you can actually access its value without any additional checks. The same thing happens here. So if it's a sum, then we can access sum.left. All clear? No questions? Okay.
Can you just, like, you mention your spatial in Scala, you can have just a partial mention what was the function, right? Can you mention those? So you don't include the else clause?
You can have nested expressions in when, but we do not have as flexible, so our pattern matching is at the moment not as powerful as in Scala. So in Scala, you can write this unapply method that actually can take any object and return a tuple of things that will be used in pattern matching. We considered implementing something like this, but for now it's postponed, so it's not in the current version of the language, and maybe it will be implemented later. So the next feature is actually the last one that I'm going to show you from the code examples part, and it's not by itself a feature of the language. It's a combination of existing features that gives a very nice effect. So this is equivalent to Groovy's HTML builders, or it's quite similar to Phantom's declarative style that was shown in the previous presentation. And what we do here is we define and we create an HTML document with some Kotlin code. And the big difference between this and, for example, what Groovy can do is this all, or what Ruby can do, that all of this is statically checked. So all of these things, these, there are actually method calls. And because these are method calls, we cannot simply write an blah, blah, blah here, because this method would not resolve and this would fail to compile. And because this is statically checked, the HTML that is produced by this code is guaranteed to be valid and to conform to the specification. Now, how do we do this? So this is a bit hard to understand. If you don't understand this right now, don't worry. It's explained in more detail on our website, but I'll just show the key parts of the implementation. So we are doing two interesting things here. So the first thing we can do is we define a unary operator plus on the string class as an extension functions. So once we do that, we can put this plus before strings here. And this funny plus sign actually gets executed as this code. So the string which is on the right-hand side of the plus becomes the THIS here, and so this code wraps it into a text element and adds it to our collection of children. So simply this adds the string as a text element inside the HTML. The second funny thing that we are doing here is we are using extension function literals. An extension function literal is similar to an extension function, but in the body of the extension function, we redefine the meaning of this, of this. And inside the body of the, and of course, this is the implicit receiver. And so we can write this, for example, and this is a method called on the instance which is passed when we are calling the extension function literal. So let me show this again. So this is the declaration of the literal. Okay, so I'm not just showing an abbreviated code example. It's actually two different classes and two different literals, but I'm just collapsing it for brevity. And so this head method is actually so this HTML function is in this context. This is actually this block is an extension function literal, and in this block, this this means an instance of the HTML class. And so when we are writing head here, this is actually means this dot head, and this dot head means calling this method. And what we do here is we create a tag, create a head tag, and we take another block and we pass it to the head tag, and this block is evaluated in the context of the head tag. So as you see, all of these, so because all of these are method calls, so we check that all of these actually exist, and we do not allow you to write anything that would be invalid. The same thing happens for attributes. I'm not showing you how attributes are defined, but it also happens in a similar way. Okay, so was that hard to understand or not? Okay, so if you didn't understand this, this is explained on our website again. So before I proceed to demo the IntelliJ plugin, I just want to describe some of the existing tooling that exists that we have already developed for Kotlin. So even though the project is on an early stage, you can already rely on a very nice environment when developing Kotlin programs. So first of all, obviously there is a plugin for IntelliJ IDEA. The plugin actually appeared before the compiler itself. So the first lines of code that were written for Kotlin were part of the plugin. And obviously, because they evolve together, so the plugin always supports all the new features of the language and so on. Second, we also have a JavaScript backend. So we can compile Kotlin to JavaScript and run it in the browser. So Java is still the top priority for us. So when we're designing the language, we focus first on the Java interop features, but we have already had very nice success with the JavaScript backend, and eventually this will allow you to write this code in the same language that runs both on the front end and on the back end of your application. Since the recent M2 release, you can write Kotlin code that runs on your Android phones. You can build your code using Ant, Maven, or Gradle, so all the standard. So if you don't want to use the IntelliJ IDEA plugin, you do not have to. You can use your favorite text editor, and there are already actually syntax highlighting support for Vim, TextMate, and Emacs, I believe. And you can use the command line build tools. We have a tool that converts Java code to Kotlin, so that it makes it easier to migrate your existing code base to Kotlin. And we have a documentation generator, and obviously there are more tools are going to be developed later. So now let me switch to my IDE and show some features of the plugin. So this is just an ordinary IntelliJ IDEA 11.1 installation. The Kotlin plugin is available in the plugin repository, so you can just go to settings plugins and find Kotlin there and install it and repeat the same thing that I'm going to show you now. So I'll start with writing a main function. So this if you have used IntelliJ IDEA, you may know what this means. This actually means public static void main, which in Kotlin we don't have, but we use the same abbreviation, and this expands to the main function. And I'll obviously start with the standard thing. A hello world. Now I right-click this, run. And it runs. Now I'm going to show some refactoring features of the plugin. So now we have a list of arguments, and we are going to transform it into an array list of greetings. So first of all, we are going to declare the array list. equals released. You see that we have completion for Java classes, and if we accept the completion variant, it automatically adds the input. So we have an array list of strings and args.for each. Is it so all red? Okay, now it's not. So yeah, the plugin is still in the early stage, so it has some bugs, and we are obviously working to fix them. Now that we have done it, we can invoke the introduce variable refactoring, which unfortunately, it actually works. So I'm entering the name of the variable here, and we see that the usage of the variable has been replaced with the usage of the expression has been replaced with the variable. Obviously, the rename refactoring works as well, so we can just rename this to greetings. So we already support several refactorings. Now I'm going to show some other nice features, and in order to do this, I'm going to declare a trait called printable with the method print self, and I'm going to provide a class that implements it. And once I do that, the plugin highlights that the class is invalid because it does not actually implement the print method, print self method. And can invoke a quick fix to have the implementation generated for me automatically. And by default, it throws an exception. I'm going to write a real implementation. Not particularly interesting, but still. Now that I have created this greeter class, I'm going to show you how easy it is to use it from Java. So I'm going to create a new Java class now. Call it Java demo. And inside this class, I'm going to reference the Kotlin class. So as you see, that code completion also works for Kotlin classes inside of Java code. And the parameter assistance as well. So it now shows me that I need to pass in a string. And obviously, completion also works for the method calls. And once I have done that, I'll show how I can use cross-language debugging to debug Java and Kotlin code running together. So actually, I need to run this. So you see that I can step through the code, and I can inspect just as easily Kotlin and Java classes in the same view. And I can also step from a Java file into the Kotlin file very easily, and then back. So you see that I have a very smoothly integrated cross-language debugging experience. And this cross-language support also works for refactoring. So for example, if I want to rename this class to something funny, I don't know. So you see that the usage in the Kotlin code has been updated. And also when this class is used from Java, the call has also been updated, and it still resolves and it still works. Beyond what I have shown, we have already implemented many other features, and for example, the structure view. So you can very easily see the structure of your Kotlin file and the classes that are defined in it. You can use the choose by name navigation to jump to a class by name, just like in IntelliJ. And there are obviously many more features that already work, but I'm not able to show all of them right now. So, going back to the slides, I'd like to summarize what I was just summarizing to say the key takeaway points from my talk. So first of all, Kotlin is ready for you to try today. So it's still in development, it still has rough edges, but we have already written a significant amount of code in Kotlin. And in general, it's a fairly nice experience. The compiler works. The IDE plugin almost entirely works, and it's still a very nice experience. Second, Kotlin fits nicely into existing projects. So in order to be able to use Kotlin, you do not need to wait until you start a new project from scratch. You can just take your existing project written in Java or in Scala or in a similar language and start writing bits and pieces of new code in Kotlin, or refactor some of the uglier pieces of your Java code into Kotlin, and keep the rest of your code base in Java, maybe forever. And this gives you the productivity advantages of Kotlin without requiring you to lose any of your existing investment in a Java code base. And finally, Kotlin is a pleasure to develop in. Now some links before I conclude. So this is a web browser demo. So you can just open this URL and try Kotlin in the web browser. It supports both the Java and the JavaScript backend. And it's a very easy way to play with Kotlin without installing anything. If you do want to install it, go to jetbrains.com/Kotlin. This is the home page of the project. It has all of the documentation, downloads, and everything. If you need more, there's a public issue tracker. You can follow us on Twitter. You can discuss with developers on the forum. You can get the source code for the project on GitHub. It's fully open source, Apache 2 license. And if you want to contribute to the development, by all means, you are welcome. And I don't know how much time I have for questions, but if you have any on Kotlin or any other JetBrains products, feel free to ask me.